Kelsey. Hey, you are studying a globe.
Yes, Professor. In our history class, we had learned about the pyramid in Egypt. I borrowed this globe from my friend to find where Egypt is located.
That's interesting. So, did you manage to find Egypt on the globe?
I'm trying to, Professor.
Well, while you try, let me welcome all our little friends watching us. Hello there. I'm Professor Total Singh. And this curious young boy next to me is my little assistant Kelsey. We welcome you to another exciting episode of Math for Juniors.
Professor, can you help me out here, please?
Sure, Kelsey. So, which part of the globe are you looking at?
Well, nowhere in particular, Professor. I'm looking all over.
That's not how you find countries on a globe, Kelsey. You need to narrow your search. To spot Egypt, you should be looking at the African continent.
Oh, you mean I need to look to the left of India?
Bullseye, Kelsey. Now you can spot it.
Here. Here it is. Got it. It's right next to Saudi Arabia.
Good work, Kelsey. Now moving from geography to math. I have an interesting question for you. What shape do you think the globe represents?
The globe is round, so it's a circle.
Sorry, my dear Kelsey, but this time you are wrong. The globe is actually a sphere.
Sphere? What's that?
You see, Kelsey, many shapes that we see in our daily life are three-dimensional. This means that they have a length, width, and depth. And a sphere is a three-dimensional shape.
So this globe is three-dimensional?
Absolutely! So let's learn some more three-dimensional shapes with Mathemagic. Look at the ball with which Sammy and this dog are playing. The shape of the ball is that of a sphere. Now, have a look at the cap which Arjun is wearing. This cap is an example of a solid shape which is called a cone. Have a look at the cold drink can which Mohit is holding in its hand. This can is cylindrical in shape.
Oh, so that's where the ice cream cone gets its name from.
Good observation, Kelsey. You are absolutely correct.
And the gas cylinder that we use in our home to cook is also a three-dimensional shape.
Right, Kelsey. The gas cylinder is indeed cylindrical in shape. How about you telling me another example of a spherical shape object?
A ball?
That example we already know, Kelsey. How about a water bubble? Do you think it's a sphere?
Water bubble? Of course, Professor. Why didn't I think of that before?
Next time, Kelsey. Meanwhile, there is another three-dimensional shape that we still need to learn about. Shall we proceed to learn about that?
Sure, Professor.
What wonderful photographs! Don't you think that all of these are similar in shape? Can you name the geometrical figure that they represent? They are known as pyramids. Let's learn how pyramid can be formed. Every polygon has a plane, and the point above the polygon is located on a different plane. When the corners of the polygon are joined to the point above, the resulting figure is called a pyramid. By definition, a pyramid is a solid figure in which one of the faces is a polygon and the other are triangles which meet at a point. Let's see the parts of the pyramid now. The polygonal region of a pyramid is called the base of the pyramid. The points at which the sides of a pyramid meet are called the vertices of the pyramid. And the perpendicular distance from a pyramid's vertex to its base is called the height of the pyramid. The lines joining the vertex to the corners of the base of a pyramid are called the slant edges.
So the kings and queens of Egypt knew about the pyramid shape back then?
Well, that's quite difficult to tell. But they certainly had very intelligent engineers who built such a magnificent structure back in that era.
Have you ever seen the Great Pyramid of Egypt in person, Professor?
Well, never got the chance yet, but I would love to see it someday. But right now, let's allow Mathemagic to tell us a bit more about these three-dimensional shapes.
Sure, Professor.
This three-dimensional object is a pyramid. Each side of a pyramid is a flat surface, and it is called the face of the pyramid. A pyramid has 5 faces. 2 faces meet at a line segment called an edge. A pyramid has 8 edges. Now, 3 edges meet at a point called a vertex. Clearly, it can be seen that a pyramid has 5 vertices. Look at this sphere. It has no edges and no vertices. Its only face is curved. This is a cone. It has 2 faces and 1 vertex, and its only edge is curved. Look at this cylinder. It has 3 faces. 2 of its faces are flat and 1 of its face is curved. It has no vertices and it has 2 edges. Now that you are well versed with the 3D shapes, do you think we can play a rapid fire in identifying shapes?
I'm all set, Professor.
Okay then. What is the shape of a drum?
Cylinder.
Good. And what is the shape of the sun?
Sun is like a ball. So, sphere. It's a sphere, Professor.
Very good correlation, Kelsey. How about a funnel? What shape does the mouth of a funnel represent?
Funnel, with which we measure oil. Its mouth is a cone, Professor. Am I right about that?
Good going, Kelsey. I hope all you kids also know these shapes as Kelsey does.
We are all bright students, Professor.
I believe you, Kelsey. But do you know that there are cone-shaped cells in the human body? Amazing, isn't it? The retina, which enables us to see, contains 2 types of cells, rods and cones. Rod cells are highly sensitive to light and they allow us to see in very dim light. These are the cells that allow humans and other animals to see by moonlight or with very little available light. The cone cells, on the other hand, are cone-shaped and are somewhere in the range of 6 to 7 millions in number. These cone cells are responsible for the color sensitivity. In simple terms, these cone cells allow us humans to experience the great beauty that color adds to our lives. Be it a beautiful flower in nature, an abstract painting, or the color of one's eyes. Different cone cells respond to different colors and help us see colorful surroundings.
Thank you, cone cells. Professor, did you notice that the shape of the globe and the shape of all the planets of the solar system are the same? So all the planets are also spherical in shape.
Bang on, Kelsey! Your mind is working overtime today.
Thank you, Professor.
Okay, Kelsey. Get back to Earth now. Well, I feel you guys are quite thorough with 3-dimensional shapes by now. Do we still need a recap?
Your call, Professor.
Well, a recap sums up the learning. So let's quickly run through it. In this module, we have learned that Sphere, cone, cylinder and pyramid are three-dimensional shapes. A pyramid is a solid figure in which one of the faces is a polygon and the others are triangles which meet at a point. The polygonal region of a pyramid is called the base of the pyramid. The point at which the sides of the pyramid meet is called the vertex. The perpendicular distance from a pyramid's vertex to its base is called the height of the pyramid. The lines joining the vertex to the corners of the base of a pyramid are called the slant edges. A pyramid has 5 flat faces, 5 vertices and 8 edges. A cone has 1 vertex, 2 faces and 1 curved edge. A cylinder has 2 flat faces, 1 curved face and 2 edges. It has no vertices. A sphere has 1 curved face. It has no edges and no vertices. Kelsey, do you know the video games that you are so crazy about are also three-dimensional? It's the 3D effect that makes the character look real.
Oh, so that's how all my favorite characters look so real. 3D effect.
Right on! I hope that from now on, every time that you all play your video games, you will remember this lesson on three-dimensional shapes.
Sure, Professor.
Good then. It's time to say our goodbyes to all the kids. From all of us at Mathemagic. Till we meet again, you all take care and be good.